All right, let's take a look at this last example. Again, the key is to be able to draw the picture and then compare adjacent side, fixed angle, opposite side, and then perhaps even find the height. Okay, so first things first, let's draw a sketch, what 55 degrees might look like. So roughly there's my 55-degree angle, and we'll call this angle B. And the side opposite, we'll call it little b, which is 18. And again, you have the choice of drawing A over here. I'm going to draw a little a over here because this is the adjacent side to the fixed angle, right? We always need to compare adjacent and fixed, or sorry, adjacent and opposite. So that's why I put little a over here. This will be capital A, this will be capital C. Okay, so right off the bat, right, you do a quick comparison. The opposite side right here is less than the adjacent side, right? Had our opposite side been greater than our adjacent side, then we know there's one triangle. But that's not the case, right? Our opposite side is less than. So if our opposite side is less than, right, we have a couple possibilities. And we're either going to have one triangle, no triangle, or two triangles. And the way we deduce whether there's one, none, or two is we have to compute what the height is in each one of these, right? So if the height is equal to the opposite side's 1, the height is greater than the opposite side is none. If the height is less than the opposite side, then we know there's going to be two triangles, okay? So let's compute what the height is. Drop down that height, and I'm going to do a quick sine of 55, opposite over hypotenuse, h over 20. Use your calculator. H is 20 sine 55, approximately 20 times sine 55 will give you 16.3. Okay, 16.38. Okay. So what does that tell us? Well, our height is less than the adjacent side. So if our height is actually less than the adjacent side and less than the opposite side, right? So our height is less than, sorry, we'll call this the opposite side. Which is also less than the adjacent side, right? We know in this problem, right, we're going to have two triangles, right? Height is less than the opposite side, less than the adjacent side, two triangles. Okay, so again, don't get confused by the variables. Just think about it as opposite side or adjacent side to the fixed angle. Okay, well, let's solve triangle number 1 here first, which is the picture that we've drawn right here. And then we'll think about what triangle 2, what a picture like that might look like. Okay, so again, just using your law of sines, right? Just kind of grind it through. Sine 55 over 18. And I'm given the adjacent side, so I'm going to find this angle right here is equal to sine of angle A over little 20, or little a, I should say. Again, right, to solve for angle A, right, you take the sine inverse of 20 sine 55 over 18 using a calculator. Okay, so based on this problem right here, if you do use your calculator, you should get about 65.5 degrees. Okay, if you enter this on your calculator. To compute what angle C is, right? Angle C is 90 minus 65.5. Which sorry, it's not 90 minus 65.5. Angle C is 180 minus 55 and minus 65.5, which will give you 59.5. Okay. All right, so I think I made a little typo. That's why I was a little paused. I made a little pause there. Okay, so on the previous problem, right, I don't know why I did a 90 minus 28. For angle A, right, you should just do 180. Made a little mistake here. 180 minus 70 minus 62, which will actually give you 82 degrees. Okay, so if you're a little confused on the previous video, little typo, little correction there. I was thinking that the other two angles were 90, but it's actually 180 minus 70 minus 62. Okay, 82. And before I make the same mistake over here, right, I was like 180 minus 55 minus 65.5. Okay, so that computes triangle number 1. And how does triangle number 2, what does that look like? Well, remember, if this guy right here is a hinge, right, think of this part right here just kind of swinging over to this side. It would look something like this. So if I were to draw this picture right here, my triangle number 2 would look like this. A is still 20. B is still 18. This will still be my angle C. And this will be my angle A. Okay, so that's what triangle number 2 would look like. Okay, now the question now is how do I compute what angle A is? Well, if you think about it, right, in this picture right here, this is 65.5, right? And these two sides are the same, right? So if this is 65.5, this guy right here is also 65.5, right? So if this part right here is 65.5, which is this, okay, so this is not the new angle A. The way to figure out the measurement of angle A, right, the measurement of angle A is 180 minus 65.5. Okay, so that would be your new angle A, which is 114.5. And now you can use your law of sines to compute the remaining angles and sides. Okay, so the measurement of angle C, right, is 180 minus 55 minus 114.5, which is 180 minus 55 minus 114.5, which is 10.5 degrees. Okay, and little c, right, you can compute what, little c is right here, question mark. You could use law of sines again. So you could say sine of 10.5 degrees over little c is equal to sine of, I'm going to use 55 over 18. Sine of 55 over, this should be 18 over here. I don't know why I wrote 18. That looks like a degree symbol. It's 18 over 18. Okay, so you can cross multiply, solve for little c. Without showing the work, you should get approximately 4.0. Okay, so the key is to draw that picture. Again, I apologize for making this simple computational error, right? It's 180 minus 55 is 65.5. You know, I would recommend you draw the picture to help you visualize to solve these problems.